Okay, good afternoon everyone. Today I am going to discuss about the grid and cloud computing subject, unit 3. So coming to the topic, in the previous video class we have discussed the introduction of the cloud deployment model, and we have discussed some deployment models, that is public, private, community and hybrid clouds. And now I'm going to continue the same cloud and deployment model. In this we are having some advantages and disadvantages of the cloud computing. So we can say here is pros and cons of the cloud computing. So what is mean by pros and cons? So now only I told that is the advantage and disadvantages of the cloud computing. So in cloud computing we have 3 pros and 3 cons. Okay, so what are the 3 pros? So improved disaster recovery, increased collaboration and flexibility, environmentally friendly. Okay, that is called the cloud computing pros, 3 pros. Okay, so and 3 cons are called internet connectivity, ongoing cost, security. So these are the 3 cons. These are the advantages. Pros are the advantages, cons are the disadvantages. Okay, so individually we will discuss what is these pros and cons. So first one is improved disasters recovery. Okay, so moving our business data to the cloud can make disasters recovery, so that is retrieving data in the event of the hardware comprises easier and less expensive. So okay, and we can even set up our system to back up data automatically to ensure we will be able to recover the most up-to-date information in case of emergency. So this is called the improved disasters recovery. This is the first one, that is the advantage of the cloud computing. Second advantage is increased collaboration and flexibility. Increased collaboration and flexibility. So what is mean by increased collaboration and flexibility? From many businesses moving to the cloud increases opportunities for collaborations between employees. Colleges can synchronize and work on document or shared apps with easy, often simultaneously receiving updates in real time. So additionally, cloud computing allows each team member to work from anywhere. The cloud centralize our data, which means that our employees and even our clients can access our company data from any location with internet access. So that is called increasing the collaboration and flexibility. So this is the second advantage of the cloud computing. Third one is environmentally friendly. So cloud computing decreases a business carbon footprint by reducing energy consumption and carbon emissions by more than 30%. For small companies, the decreased energy usage can reach 90%, a huge money saver. It can also help a business project and eventually sound image. So this is called the environmentally friendly. So these are the 3 advantages, and we can say 3 pros of the cloud computing. So what is the 3 cons of the cloud computing? Internet connectivity. So what is mean by internet connectivity? So if you see this internet connectivity, so running all or some of our business applications in the cloud is great, as long as we can maintain a consistent as long as we can maintain a consistent internet connection. If any one of our cloud-based services providers losses connectivity, or if our ISP experience an outage, we are out of business until that internet connection returns. Even the best servers go down occasionally. So if we decide to use this method, it is important to implement a backup plan. So internet connectivity, it is called internet connectivity. Next one is ongoing cost. What is mean by ongoing cost? So while cloud computing we pay the same amount, so while cloud computing is relatively inexpensive to start up, depending on our needs and in-house solutions, many cost less in the long run. Buying an in-house server and installing a network system is definitely a large upfront capital investment, and we also need to consider ongoing IT maintenance cost. So with the cloud computing, we pay the same amount each month to maintain not only our server but also all our data. The choice we make may depend on whether the choice can be depend whether the choice will be depend whether we have a lot of startup capital to invest in a private network. We should be sure to compare all the costs for supporting both an in-house server and cloud-based server to see which option works best for our situation. Okay, so this is called the ongoing cost. Third one is a security. So next, coming to security, third one. So it boils. So it boils down to whom to do we trust with our business data. Not every business should place its data in the cloud. So companies with a highly sensitive data or that must be stringent compliance regulations may well need their own IT department to keep data secure. So when we store data in the cloud, we trust a third party to keep it safe. So this is called the security. So these are the advantages and disadvantages of the pros and cons. Okay, and next coming to implementation levels of virtualization. Okay, so this is the next topic. So we are now going to discuss this implementation levels of virtualization. So what is mean by implementation levels of virtualization? So implementation is a computer architecture technology. Okay, implementation is a computer architecture technology by which multiple virtual machines VM are multiplexed in same hardware machine. Okay, so having the diagram, if you see the diagram, we can understand easily. So virtualization is a computer architecture technology by which multiple virtual machines means VM machines are used in this computer architecture. Multiple virtual machines are used in this architecture are multiplexed in the same hardware machine. The purpose of VM is an enhanced resource sharing by many users and improve the computer performance in terms of resource utilization and application flexibility. So in order to maintain the computer very flexible and its performance, to improve the performance levels of the computer, so we are sharing many users in this technology. Okay, for the purpose of virtual machines. Okay, this idea, the idea is to separate the hardware from the software to yield better system efficiency. So a traditional computer runs with a host operating system and specially tailored for its hardware architecture, as we have the diagram. So after virtualization, different user applications managed by their own operating system, that is guest operating system, can run on the same hardware independent of the host operating system. So this is done by the adding additional software called virtualization layer. Okay, so if you see the diagram, we can understand this is the actual diagram. This is the traditional traditional computer. This is after this is our normal computer. The computer after virtualization, it will be there, look this like. Okay, so traditional computer, how it works? The traditional computer runs with a host operating system. The traditional computer runs with a host operating system, especially tailored for its hardware architecture. This is the hardware architecture. So this is the hardware. This layer is the hardware. In this hardware, we are having different resources like devices, drives, storage. These are the different resources available in the hardware and hardware architecture. And after virtualization, after the traditional computer is virtualized with the different users. Different users means applications we are having managed with their operating system. So managing with their own operating system, that is guest operating system, and run with the same hardware. And we having the hardware running running with a host operating system. So in this also we having the same, okay, same resources available in the hardware running. So it is these hardwares are running with the host operating system. Okay, so independent host operating system, additional software we are having. Okay, here we are having the additional software called virtual layer. This is the additional software. In this we are in traditional computer we doesn't have the additional software, that is a virtual layer we doesn't have. We can say it is a hypervisor and virtual machine layer. Okay, so this is the additional we have attached in this after virtualization. So okay, and this is the main diagram of the virtual level virtualization. Okay, so this is the traditional computer, this is the virtualization. So this is the virtualization is a computer architecture technology. In this we are having the virtual machines. In this we are having the virtual machines which is multiplexed with the hardware machine, The purpose of virtual machine is to enhance the resource sharing with many users, in order to improve the computer performance in terms of resource utilization and application flexibility. So this idea is to separate the hardware and software to yield better system efficiency. So this is called after virtualization. This is before virtualization. It means it is a traditional computer. It is after virtualization. We can say it is a after virtualization. Okay. So in this virtualization technique, which allows the shared signal physical instance of an application or resource among multiple organizations, that is to customers. It does so by assigning a logical name to the physical resource and providing a pointer to the physical resource on demand. So coming to the virtualization, so a concept. Creating a virtual machine over the existing operating system and hardware is referred as a hardware virtualization. Virtualization provides an environment that is logically separated from the underlying hardware. The machine on which the virtual machines is created is known as host machine, and virtual machine is referred as a guest machine. Okay, and this virtual machine is managed by the software or firmware which is known as hypervisor. Okay. So next we have this is the diagram we have seen now only. So next this is the application levels. So in the application in this virtualization can be implemented at various operation levels. Virtualization can be implemented in various operation levels as seen in this diagram. So these levels are called, the levels comes from the downwards: instruction set architecture, ISA level, hardware level, okay, operating system level, library level, application level. So these are the different operational levels available in the virtualization. So these are explained individually here. So what is mean by instruction set architecture? Architecture level. So what is the mean of that? So what we have learned in this instruction set architecture level. Okay. So in this instruction set architecture level, we are having virtualization is performed by emulating is given instruction set architecture by the instruction set architecture of the host machine. Okay, emulating a given instruction set architecture by the instruction set architecture of the host machine. The basic emulation method is through code interpretation. So an interpreter program interrupts the source instructions to target instruction one by one. So one resource instruction may require tens or hundreds of native target instructions to perform its function. Obviously, this process is relatively slow. So for better performance, dynamic binary translation is here. So for better performance, this is the better performance, dynamic binary translation. Binary translation is desired. So these blocks can also be extended to program trace or super blocks to increase translation efficiency. A virtual instruction set architecture thus requires adding a processor specific software translation layer to the compiler. Okay, so in this this is called the instruction set architecture level. So second one is a hardware abstraction level. So it is performed right on top of the bare hardware and generates a virtual hardware. So environmental for an virtual machine. On other hand, the process manages the underlying hardware and through virtualization. So the idea of this virtualization, a computer resource such as its processors, memory and input-output devices, so as hardware virtualization rate by multiple users concurrently may be upgraded. So this is called hardware abstraction level. Next, operating system level. So operating system level virtualization creates containers on a single physical server and operating system instance to utilize the hardware and software in data centers. The containers behave like real servers. OS level virtualization is commonly used in creating virtual hosting environments to allocate hardware resource among a large number of mutually distrusting users. This is called operating system level. So next one is library support level. So virtualization with library interface is possibly by controlling the communication link between application and the rest of the system through application programming interface hooks. The software tool Wine has implemented this approach to support Windows application on top of Unix hosts. Another example is that vCUDA, which allows application existing within virtualization machines to leverage graphical processing unit hardware accelerations. So this is called library support level. Next, application level. We can say it is a user application level. So on additional operating system, an application runs as a processor's application level virtualization is also known as processor level virtualization. The most popular approach is deploying the high level language virtual machines. In this scenario, the virtualization layer exports an abstraction of virtual machine that can be run programs written and compiled in a particular abstraction machine. Any program written in high level language and compiled for this virtual machine will be able to run on it. The Microsoft .NET CLR and Java virtual machines are two good examples of this class virtual machine. Other forms of application level virtualization are known as application isolation and application sandboxing or application streaming. The process involves wrapping the application in a layer that is isolated from the host operating system and other applications. So the result is an application that is much easier to distribute and remove from user workstations. Okay. So this is called the user application levels. Next, virtualization support at operating system level. Okay, operating system level. It is slow in initializing the hardware level virtualization machine because each virtual machine creates its own image from scratch, and storage of such images are also slow. Operating system level virtualization provides a feasible solution for these hardware level virtualization issues. Operating system virtualization inserts a virtualization layer inside an operating system to partition a machine's physical resource. The multiple virtual machines within a single operating system kernel. So this kind of virtual machine is called virtual execution environment. So this virtual environmental its own set of processors, file system, user accounts and network interface with IP addresses, routing tables, firewalls, firewall rules and other personal settings. So these are the virtualization support at operating system levels. So we are having some advantages in this virtualization. So that is virtual machines at operating system level have minimum startup shutdown costs, low resources requirements, and high scalability. It is possible for virtual machine and its host environment to synchronize the state changes when necessary. So these are called the implementation levels of operations of the virtualization. Okay, so next coming to virtualization structure. So what is mean by virtualization structure? So in this there are three typical classes we are having in the virtualization architecture. Okay, virtualization architecture, and the architecture of this machine before and after virtualization. Before virtualization, the operating system manages the hardware. After virtualization, the virtualization layer is inserted between the hardware and the operating system. Okay, and the operating system. So once I'm repeating the same point. Before virtualization, the operating system manages the hardware. After virtualization, a virtualization layer is inserted between the hardware and the operating system. In such cases, if you see the diagram, we can understand very clearly. So this is the diagram. This is the before virtualization. This is the after virtualization. Before virtualization, what we are saying that virtualization operating system. The operating system here, host operating system is there, no? So the host operating system managing the hardware here. After virtualization, so a virtualization layer is inserted between the hardware and the operating system. Okay, in such cases, the virtualization layer is responsible for converting the portions of the real hardware into virtual hardware. Depending on the position of this virtualization layer, there are several classes of virtual machines architecture, namely hypervisor architecture, para-virtualization, host-based virtualization. So this hypervisor architecture, we can say Zen architecture. Okay, we can also call Zen architecture. So next coming to hypervisor. What is mean by hypervisor? So depending on the functionality, a hypervisor can assume a microkernel architecture or a monolithic hypervisor architecture. A microkernel hypervisor includes only the basic and unchanging functions such as physical memory management and processor scheduling. So the device drivers and other changeable components are outside the hypervisor. The monolithic hypervisor implements all the mentioned functions, including those of the device drivers. So therefore, the size of the hypervisor code of a microkernel hypervisor is smaller than that of monolithic hypervisor. Okay, so in this hypervisor, we support the hardware level virtualization on bare metal device like CPU, memory, disk, and network interfaces. So okay, so in this network interfaces, the hypervisor software sits directly between the physical hardware and its operating system. Okay, so the virtualization layer is referred as either the VMM or the virtual hypervisor. So this is the diagram. So this is in this diagram. So virtualization layer, what they are saying, the virtualization supports the hardware level virtualization and bare metal devices like CPU, memory, disk, and network interfaces. In the hypervisor, software sits directly between the physical hardware and its operating system. So virtualization layer is another name we can referred as VMM or hypervisor. A microkernel hypervisor includes only the basic and unchanging functions, that is, we can say now only, that is physical memory management and processor scheduling. Okay, so this monolithic hypervisor implements all the functions, including those device drivers. Okay, so this is called the hypervisor. Next is Zen. What is mean by Zen architecture? So Zen architecture, Zen is an open source hypervisor program developed by the Cambridge University. Okay, developed by the Cambridge University. Zen is a microkernel hypervisor which separates a policy from the mechanism. The Zen hypervisor implements all the mechanisms, leaving the policy to be handled by domain 0. So it just domain 0, it just provide a mechanism by which a guest operating system can have direct access to the physical device, and the core components of the Zen systems are the hypervisor, kernel, and applications. The organizations of these three components is important. Like other virtualization systems, many guest operating systems can run on the top of the hypervisor, okay. And the guest operating system, so the guest operating system, privileged operating guest operating system which can control ability is called domain 0. So this is the domain 0. This is Xenon Linux, Xenon Windows. This is the Zen hypervisor. This is the hardware device. So this is the diagram of the Zen architecture, and now I explain this about this. So okay na? So this is a Zen is an open source hypervisor program developed by the Cambridge University. Zen is a microkernel hypervisor which suppresses the policy of mechanism. It implements all the mechanisms leaving the policy handled by the domain 0, and Zen does not include any device drivers natively. In this mechanism, operating system can be directly access the physical devices, and this control ability is called the domain 0, and in the domain U, it is loaded when Zen boots without any file system drivers being available. So domain 0 is designed to access hardware directly and manage the devices. So binary translation with full virtualization. Binary translation with full virtualization. Depending on the implementation technologies, hardware virtualization can be classified into two categories: full virtualization and host based virtualization. Okay. So this is the hypervisor, this is the diagram of the type 1 hypervisor. In this we are having the guest operating systems and hypervisor system software. So this is the second one, hypervisor. In this we have guest operating system, hypervisor, host operating system. Okay. So this is the second hypervisor. So what we are saying in this, we are having the full virtualization and host based virtualization. So what is mean by full virtualization? So with full virtualization, non-critical instructions run on the hardware directly, while critical instructions are discovered and replaced with the traps into the virtual VMM to be emulated by the software. Okay. So both the hypervisor and virtual machine approaches are considered full virtualization. Non-critical instructions do not control hardware or threaten the security of the system, but critical instructions do. So running the non-critical instructions on hardware, running the non-critical instructions on hardware not only can promote efficiency but also can ensure system security. Okay. So this is called the full virtualization. So next one is host based virtualization. So host based an alternative virtual machine architecture is to install a virtualization layer on the top of the host operating system. This host operating system is still responsible for managing the hardware. So the guest operating systems are installed and run on the top of the virtualization layer. First, the user can install this virtualization architecture without modifying the host operating system. When virtualizing software can rely on the host operating system to provide device drivers and other low level services. So second is the host based approach appeals to many host machine configurations. So comparing to the hypervisor VMM architecture, the performance of the host based architecture may also be low. Okay. So this is called the host based virtualization. Next, coming to diagram of this host based virtualization. So in this host based virtualization, we are having the ring 0, ring 1, ring 2, ring 3. Okay, so having the host computer system hardware. Okay, so this is the direct this is the user application, and this is the guest operating system, and this is the VMM. So okay, and binary translation of the operating system request. Okay, and direct execution of the user request. So whenever the user give the request, that request is moved to the host computer and it will be directly executed. So whenever the guest operating system is want to execute some translate some request, it will be moved to the virtual machine VMM, that is called virtualization level layer, or we can say hypervisor, and it will be sent to the host computer system hardware. So then only it will be solved. Okay, the user application will be moved directly to the host computer system hardware, but when the guest operating system is asking any question request from the host computer, it will be first moved to the virtual machine where, and I'll means hypervisor, and it will be passes to the host computer system hardware. Okay, so this will be solve the information and it will be passes to the virtual machine where, and after that guest operating system. So for this user application, it will be directly moved to the user application. So this is the indirect execution of the complex instructions via binary translation of the guest operating system request using the VMM plus direct execution of simple instructions on the same host. So this is the working of this diagram. So next, coming to emulation virtualization. In the emulation, the virtualization machine stimulates the hardware and hence becomes independent of it. In this guest operating system does not require modifications. Okay, so this is the kernel, and this is the guest operating system, this is the host operating system, and in this also we have kernel, this is the virtual machine, and we having the software here. So between the kernel and the virtual machine having the transactions, and after that system hardware. So this is the working of this. So this like, okay, zigzag shape it will be translates the messages. Okay, and next come to para virtualization. So it needs to modify it. It needs to modify the guest operating system. A para virtualized VM provides special application programming interface requiring substantial operating system modification in user applications. Performance degradation is a critical issue of the virtualized system. So the concept of the para virtualized virtual machine architecture, the guest operating system are para virtualized. They are assisted by an intelligent compiler to replace the non-virtualizable operating system instructions. So the hypercalls, the traditional microprocessor x86 processor offers 4 instruction execution rings, that is ring 0, 1, 2, 3. Okay, 0, 1, 2, 3. The lower the ring number, the higher the privilege of the instructions being executed. The operating system is responsible for managing the hardware and the privileged instructions to execute at ring 0, while user level applications run at ring 3, and although the para virtualization reduces the overhead, it has incurred problems like compatibility and portability, because it must support the unmodified operating system as well. The second, the cost is high because they may require deep operating system kernel modifications. Finally, the performance advantages of para virtualization varies greatly due to workload variations. Okay, so this is called the para virtualization, and having the diagram, this is the diagram of the para virtualization. Having the application, this is the para virtualized guest operating system, and these are the rings 0, 1, 2, 3. So user application is running on the host or computer system hardware. Okay, and executing the data, and para virtualized guest operating system is passing to the virtualization layer. After that, it sends to the hardware host computer system hardware. So this is the diagram of the para virtualization, and okay, and this is the explanation of the para virtualization. Okay, next To support the virtualization processors such as multiplexer, microprocessor, employ a special running mode and instruction known hot okay, special run. Okay, this is called the working of this virtualization. Okay, next coming to so in the next class we will discuss about the virtualization of CPU, memory and input output device. Thank you for everyone. So in the next class we will discuss about the virtualization, para virtualization with compiler.